Hello and welcome to Call of Chemistry. This will be the fifth and final video regarding some basic concepts of chemistry series. In this video, we will solve some numericals. So let's start. So the first problem tells, in a mixture of oxygen and nitrogen gases has the ratio 1:4 by weight of oxygen and nitrogen gas respectively. So we have to find out the ratio of number of molecules of oxygen and N2 in the mixture. Suppose weight of O2 in the mixture is x gram and weight of N2 in the mixture is 4x gram, as the ratio is 1:4, and we know that the molar mass of O2 is 32 gram per mole and molar mass of N2 is 28 gram per mole. In other words, 32 gram of O2 corresponds 6.022 into 10 to the power 23 or any number of O2 molecules. So 1 gram of O2 corresponds Na upon 32 number of O2 molecules. So here the weight of oxygen is x gram. So x gram of O2 corresponds Na into x upon 32 number of O2 molecules. Similarly, for x gram of nitrogen corresponds Na into 4x upon 28 number of N2 molecules. So we can see, we calculate the number of molecules of oxygen and nitrogen gas in the mixture. So we can take the ratio. So Na into x upon 32 is to Na into 4x upon 28. Na into x upon 32, if we simplify that, this will be 7. So Na into x upon 7. Then this Na into x term cancels out. So we get the ratio 7:32. So the option D will be correct. So we move on to the next problem. So here we have to calculate the volume of carbon dioxide released when 9.85 gram of barium carbonate completely dissociates. So we write the equation. When barium carbonate dissociates, it gives barium oxide and carbon dioxide, and this is 1 mole and this also 1 mole. So molecular weight of barium carbonate is 137 plus 12 plus 16 into 3 gram per mole. So it will be 197 gram per mole. Again, you know that at STP 1 mole of carbon dioxide gas corresponds 22.4 liter of CO2 gas. So from that reaction, we can say that 197 gram of barium carbonate dissociates to give 22.4 liter of carbon dioxide gas. So 1 gram of barium carbonate dissociates to give 22.4 upon 197 liter of carbon dioxide gas. So here the weight of barium carbonate given that 9.85 gram. So 9.85 gram of barium carbonate dissociates to give 22.4 into 9.85 upon 197 liter of carbon dioxide gas. So we can get the value is 1.12 liter of carbon dioxide. So the option B will be the correct option. So we move on to the next problem. Here the problem tells at 523 Kelvin temperature and 1 atmospheric pressure, how much volume of gas produced if 5 gram of ammonium nitrate dissociates as follows. So here you see that this is 2 mole and nitrogen gas produced is 2 volume, oxygen gas is 1 volume and water vapor produced is 4 volume. So at STP the volumes will be 22.4 into 2 liter, here 22.4 liter and here 22.4 into 4 liter. As in STP 1 mole or 1 volume of gas contains 22.4 liter of the gas. So here 2 volume means 22.4 into 2 liter of nitrogen gas is there and 4 volume of water vapor means 22.4 into 4 liter of water vapor is there. So this is 44.8 liter, this is 22.4 liter and this is 89.6 liter. So total volume of all gas produced is 44.8 plus 22.4 plus 89.6 liters, that is 156.8 liter. So we can find the total volume of all gas produced is 156.8 liters. But here the condition is not STP. Here the condition is 1 atmospheric pressure and 523 Kelvin temperature. STP means 1 atmospheric pressure and 273 Kelvin temperature. So we have to calculate the volume of all gases at this condition, that is 523 Kelvin and 1 atmospheric pressure. How can we do that? We all know the combined law of gas, that is P1 V1 upon T1 is equal to P2 V2 upon T2. This comes from PV upon T is equal to constant. This is combined law of gas, where P1 is the initial pressure, V1 is the initial volume and T1 is the initial temperature and P2 is the final pressure and V2 is the final volume and T2 is the final temperature. So we have to put the values where P1 is 1 atm, V1 is, we have calculated that at STP the total volume is 156.8 liter, so it will be V1 and T1 at STP the temperature is 273 Kelvin, and P2 in the reaction condition P2 is 1 atm, and T2 it is 523 Kelvin temperature, and we have to calculate the V2. So simply put those values upon 273 is equal to, so we can calculate the V2. V2 will be 523 into 1 into 156.8 upon 273. So this will be 300.389 liter. Oh, this is the volume of total gases at this reaction condition. Now we have calculated the total volume of gases when 2 moles of ammonium nitrate dissociates, but here this the weight of the ammonium nitrate given is 5 gram. So the molecular weight of ammonium nitrate is 14 plus 4 plus 14 plus 16 into 3 gram per mole. This is 80 gram per mole. Therefore 2 moles of ammonium nitrate means 2 into 80 gram, that is 160 gram of ammonium nitrate is used. Hence this 160 gram of ammonium nitrate gives this amount of this volume of total gases. So 160 gram of ammonium nitrate gives 300.389 liter of gases. So 1 gram of ammonium nitrate gives 300.389 upon 160 liter of gases. So 5 gram of ammonium nitrate gives 5 into 300.389 upon 160 liter of gases. So this is 9.387 liter of gases. So this is the answer. So 5 gram of ammonium nitrate gives 9.387 liter of all gases. So we move on to the next problem. So the problem 4 tells relative density of a solution of nitric acid, that is 60% weight by volume, is 1.46, and we have to calculate the required weight of nitric acid in grams to react with 5 gram of cupric oxide. So we have to write the reaction, that is cupric oxide plus HNO3 plus H2O, and we have to balance the equation, that is 2HNO3, and I see that 1 equivalent of copper, 1 equivalent of copper, 2 equivalent of hydrogen, 2 equivalent of hydrogen, and 2 equivalent of nitrogen, 2 equivalent of nitrogen, 6 equivalent of oxygen, and here also 6 equivalent of oxygen. So the reaction is balanced, and we see that 1 mole of cupric oxide reacts with 2 mole of nitric acid to give these products. So we have given that molecular weight of cupric oxide is 79.5 gram per mole, and 5 gram of cupric oxide means 5 upon 79.5, that is 5 gram, and it is gram per mole. So we get the moles corresponding 5 gram of cupric oxide, that is 0.06289 moles of cupric oxide. And we know the molecular weight of nitric acid is 1 plus 14 plus 3 into 16 gram per mole, that is 63 gram per mole. On the reaction, you can see that it is 79.5 gram, and it is 2 into 63, that is 126 gram. So from the reaction, we can say that 79.5 gram cupric oxide reacts completely with how much amount of nitric acid, that is 126 gram of nitric acid. So 1 gram cupric oxide reacts completely with 126 upon 79.5 gram of HNO3. So 5 gram of cupric oxide reacts completely with 126 into 5 upon 79.5 gram of HNO3. So you can get the value 7.924 gram of HNO3. In the problem, it is told that the HNO3 is 60% weight by volume. So that means 100 ml of HNO3 solution contains 60 gram of HNO3. So here 5 gram of cupric oxide completely reacts with 7.924 gram of HNO3. So in other words, we can say that 60 gram of HNO3 is in 100 ml of HNO3. So 1 gram of HNO3 is in 100 upon 60 ml of HNO3, and 7.924 gram of HNO3 contains 100 upon 60 into 7.924, that is ml of HNO3, that is 13.206 ml of HNO3. Now we have given the relative density of nitric acid, that is 1.46. So relative density is mass upon volume. So we have given the relative density, that is 1.46. So 1.46 is mass of HNO3 in grams upon volume. So we have calculated the volume, that is 13.206 ml, that is 13.206 ml. So you can calculate the mass of nitric acid in grams, that is 13.206 into 1.46 gram, that is 19.28 gram of HNO3. So the amount of HNO3 required in grams is 19.28, that is 19.28 gram to react with 5 gram of cupric oxide completely. So move on to the next problem. Problem 5 tells 24.5 gram of potassium chlorate is heated to give oxygen, which is allowed to react completely with hydrogen obtained from zinc and H2SO4 reaction. The weight of zinc required for this purpose would be, so we can write the equation, that is so we have to balance the equation. So 2 KClO3, that is 2 KCl plus 3O2. So 2 potassium are there, 2 potassium, 2 chlorine, and 6 equivalent of oxygen. Here also 6 equivalent of oxygen. So here you can see that 2 moles of potassium chloride dissociates to give 3 moles of oxygen, and molecular weight of potassium chlorate that is atomic mass of potassium is 39 plus 35.5 plus 16 to 3 gram per mole, that is 122.5 gram per mole. So 1 mole of potassium chlorate contains 122.5 gram of potassium chlorate. Hence 2 moles of potassium chlorate means 2 into 122.5 gram, that is 245 gram of potassium chlorate. So you can say that 245 gram of potassium chlorate gives 3 moles of oxygen. Here you can say that 2 moles of potassium chlorate dissociates to give 3 moles of oxygen. So in other words, 245 gram of potassium chlorate gives 3 moles of oxygen. So here the weight of potassium chlorate is 24.5 gram. So 1 gram of potassium chlorate gives 3 upon 245 moles of oxygen. 24.5 gram gives 3 into 24.5 upon 245 moles of oxygen, that is 0.3 moles of oxygen, and this oxygen reacts completely with H2, and we know the equation O2 plus H2, that is H2, and if we balance the equation, 2 oxygens is there, 2 oxygens, so here it is 2, and it's 4 equivalent to hydrogen, so here it is 2. So we can say from the reaction that this is 1 mole, this is 2 mole. So 1 mole of oxygen completely react with 2 mole of hydrogen. So 0.3 moles of oxygen reacts with 2 into 0.3 moles of hydrogen, that is 0.6 moles of hydrogen. This 0.6 moles of hydrogen comes from the reaction with zinc with H2SO4. So you know the reaction zinc plus H2SO4 to give ZnSO4 plus H2. One equivalent of zinc is there, so one equivalent zinc also is here. 2 equivalent of hydrogen, 2 equivalent of hydrogen, 1 equivalent of sulfur, 1 equivalent of sulfur, 4 equivalent of oxygen is there, 4 equivalent of oxygen is there. So reaction is balanced. So from this reaction we can see that 1 moles of zinc reacts with 1 mole of H2SO4 to give 1 mole of hydrogen. So here we can see that 0.6 moles of hydrogen is required. So 1 moles of hydrogen is released from 1 mole of zinc. So 0.6 moles of hydrogen from 0.6 moles of zinc. Now atomic weight of zinc is given that 65. So moles of zinc, that is weight of zinc upon atomic mass, that is 0.6 moles is required, and the weight of zinc we have to calculate. Atomic mass is 65, is given 65. So weight of zinc is 65 into 0.6 gram, that is 39 gram. So that is the answer. So 39 gram of zinc is required for the purpose. So that is the solution. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, share and subscribe my channel. Thank you.